Okay, so we're starting Chapter 6 today, and a lot of Chapter 6 is dealing with rational exponents. And today we're going to talk about nth roots of rational exponents and then how to solve some roots. I do have an exponent sheet that I'm going to give y'all. I'm going to go ahead and do that now while I have it on my mind. I've made it blue so that hopefully it will stand out in your notebook. It's got a bunch of squares. It's got cubes. It's got fourth roots and fifth roots and a bunch of them. So this is very handy, so that's why I made it blue. Hopefully it will stick out. Your notebook, do not lose it. And I'm sorry about the silly line it made through with copy machine. We just need copy machine. Anyway, did everybody get one? All right. So the nth root of A, and A is just a number. The n is the root that you're taking. So we know about square roots, right? We've done a lot with square roots. We also have cube roots and fourth roots and fifth roots and sixth roots and any other number we can think of. So that means what times itself that many times equals the number underneath the radical. Okay, so that's what that means. N is the index. So whatever little number is in this location of a radical is called the index. So let's just talk about some roots, some common ones. First, let's talk about a to the 1/2 power. A to the 1/2 power is a square root. A 1/3 power is a cube root. And a 1/4 power is a fourth root. And I don't have this one written down, but what do you think a 1/5 power would be?
5 with the 8.
It'd be a fifth root.
Fifth root, yeah.
Mm-hmm. So if it's like 1 over a number, like this is a square root, this is a cube root, that's a fourth root, and on and on and on. So 1 over the number is whatever that root is. The denominator is the index. Okay? The denominator of the fraction is the index. So there's a table in your book, and we're basically going to copy this table. Real roots of A. So your index can be an even number or an odd number. So we got different things that happen when n is even and when n is odd. So if your term under the radical, which is your A term, if it is less than 0, which means it's negative, you will have no real roots. So if it's an even exponent, that means square roots, fourth roots, sixth roots, eighth roots, 10th roots. So if we take the square root of a negative, what do we get? An imaginary, right? So that's no real answers. We can't take the square root of a negative. You also can't take the fourth root of a negative. You also can't take the sixth root of a negative. Okay? So if you have an even index, you cannot take that root of a negative. You can with odds, but you cannot with an even index. If you have a 0 under the radical, you will have 1 real root. If your A term is a positive number, you will have 2 real roots. Because remember, we have plus or minus the nth root of A. That looks crazy. I'm trying to make it better. That's a bit better. So if we take the square root, the fourth root, the sixth root, etc., if we have a positive number, remember we got to take the plus, consider the plus and minus. Now, if your index is odd, it's a little bit different. You can take the cube root or the fifth root or the seventh root or the ninth root of a negative. So if it's negative, you will have one real root. If a is 0, you will have one real root. And if a is positive, you will have one real root. So you don't do the plus and minus thing for an odd. You just take it as it is. Okay, so if you have an odd index, taking a cube root, a fifth root, a seventh root, or whatever, you can have negatives and you only have one if it's positive. One solution for all of them. Let's talk about why that is for a second. You can't square a negative and get a positive, right? Right? If I say negative 3 squared, well, that means negative 3 times negative 3 equals positive 9. Let's say negative 3 to the third power, though. That means negative 3 times negative 3 times negative 3, which is a what? Negative 27, right? Because if I multiply these two, I get a positive 9, and positive 9 times negative 3 is a negative 27. Okay? So that's why you can't have negative solutions for an even exponent or an even index, but you can have negative solutions for an odd index. Does that make sense? Stuff like this. You have an odd number of negatives, you got a negative, and you're multiplying. You have an even number of negatives and you multiply, you end up with a positive. All right. So the directions here will say find the nth root of a. Find the nth root of a. Here's our first real example. N is 3. A is negative 216. And I need me a copy of the quiz. It's going to be handy. So, N is the index. So you're going to say a cube on the outside of negative 216. Now, if you look at the cube roots over there on the far right-hand side, is there one that says the cube root of 216? What does it say the cube root of 216 is? 6. But since it's a negative on the inside, we're going to have one real root. So the answer is negative 6. So you're saying what multiplies times itself 3 times to get negative 216? The answer is negative 6. Because negative 6 times negative 6 times negative 6 equals negative 216. So basically, if you have an odd number here and a negative, you just stick a negative there. If this is odd and this is negative, you just stick a negative with your answer. Okay? Let's do some more. So B, we have N equals 4 and A equals 81. So what number is my index? A or N? N. Get it? N. Index. Ha ha. Get it? Okay. So that goes on the outside of the radical. The inside of the radical is your A. All right. So look down at your fourth roots. What does it say the fourth root of 81 is?
3.
3. But 4 is an even, right? And we're taking it of a positive. So we say plus or minus 3. Does that make sense?
Well,
All right, let's do one more, then you guys are going to try one. N equals 3. A equals negative. What goes on the outside of the radical? What goes on the inside? 3 is my index, and my A is negative 64 is my radicand. Y'all know that's the name of something under the radical. It's called a radicand. So, is my answer going to be a positive, a negative, or a plus and minus?
A negative.
A negative, because I'm taking the cube root of a negative, so it can be a negative.
You're doing it 3 times.
Look at your sheet. What's the cube root of 64?
-4.
That's right. Far right side. The cube root of 64 is 4. Yeah. Y'all see, like, the first 2 columns are all squares and square roots. The third columns are cubes, then fourths, then fifth powers. And so then you have cubed roots, fourth roots, fifth roots. Does that make sense? Okay. I want y'all to try this one really quick on your paper. N equals 4. A equals 0. So set up your radical and then use your sheet to help you. Got it? What'd y'all get? Plus and minus 5. So you took the fourth root of 625. Even means you got a plus or a minus. And you look at your chart. What multiplies times itself, 4 times to get 625 is 5. So raise your hand if you got plus and minus 5. Questions? All right, good. Because it's an even exponent of a positive number. And that chart we made, an even exponent with positive, you have 2 roots, plus or minus. So it matters. Okay. Next thing we're going to do is we're going to evaluate these. And we're going to do it this time without the calculator. And in a little while, we'll learn how to do it with our calculator. And it's very important that you follow directions here because on your practice, you're going to have to do it some without the calculator, some with the calculator. So this is example what? D? All right. Fractional exponent, 16 to the 3/2 power. So they're going to give you a number raised to a fractional exponent. Now, here's what you're going to do. The denominator is going to be your index. Okay? So that's a 2 in the denominator, so we're going to take the square root of the big number. And then we're going to raise the whole thing to the numerator. So let me color code them. This goes here, and this goes here. Y'all pay attention. Y'all with me? Your denominator is your index. Your numerator is going to be the exponent for the whole problem. The big number goes under the bracket. Okay? And then what we're going to do is we're going to take the square root and we're going to raise it to the 3rd power. Okay? So y'all tell me, what's the square root of 16? 4. So I'm going to say 4 to the 3rd power equals what? 64. There's your answer. It's that easy. Really, really. So, let's do some more. This one, 125 to the 2/3 power. So which one is my index? The 3. So it's a cube root of 125. And then I'm going to raise everything to the 2nd power. Denominator is your index. Your numerator is your power of everything. So first you do your inside your parentheses. So what is the cube root of 125? 5. So your answer is 5 squared, which is 25. Does that make sense? All right, let's do a negative exponent. So that's 8 to the negative 4/3 power. So remember in chapter 8, anytime we had a negative exponent, we moved it to the other part of the fraction, right? So whole numbers went to a denominator. So that's what we got to do. We got to put that in a denominator. So this is going to be 1 over 8 to the positive 4/3. Negative exponents have to go to the denominator. Negative exponents need to go to a denominator. So then you do the same thing with that denominator as you did. You're going to keep the 1 on top. What's my index for the 4/3 power? So it's the cubed root of 8, all raised to the 4th. You can just do that underneath. What's the cubed root of 8? 2. So this is 2 to the 4th power in the denominator. So what is 2 to the 4th power? 16. So it's 1 over 16. So if you have a negative exponent, just stick it in the denominator and then evaluate your powers down there. Okay? So you do the root and then you raise it to the exponent. Let's do another negative one. 32 raised to the negative 3/5. KD, eyes open, please. So what's the first thing we do with a negative exponent? Yep, so we move it to the denominator. So it's going to be 1 over, how do I set up my radical? So the 5th root of 32, and I'm going to cube everything, right? Y'all understand how this gets set up? Denominator, numerator. Denominator, numerator. Always, always. Does that make sense? Everybody? This is simple stuff. It really is simple. This goes here. This goes here. All right, so using your chart, what's the 5th root of 32? 2. And what is 2 to the 3rd power? So the answer is 1/8. Does that make sense? So if you have a negative exponent to start with, you got to make it a fraction. Put it in the denominator. All right, I got a couple of tries for you guys right here. That means everybody gonna work them out. 4 to the 5 over 2. $81 to the 3/4. And that's it. Y'all work those 3. Set up your radicals and do your charts. Denominator is your index. Check your 3 answers when you got them. Somebody close. All right, can somebody tell me how I set up number 1 as a radical? KD, what root on number 1? What's my index? 2. So we take the square root of 4, and then I do what with it? I didn't ask that. I'm setting it up. How do I set it up? Thank you. Yeah. So my denominator goes as my index. The numerator is my power for the whole thing. What is the square root of 4? What's the square root of 4? 2. 2 to the 5th power equals what? 32. Raise your hand if you got 32. Any questions? All right, number 2, I have a negative exponent. So what's the first thing I have to do to number 2? So it's going to be 1 over 9 to the 1/2. Yes, and you can put it to the first power. But didn't at the very beginning I told you that a 1/2 power is just a square root? I think there was like 3 I gave you at the very beginning. So it's just 1 over the square root of 9. And what's the square root of 9? 3. So the answer is 1 over 3. So raise your hand if you got 1/3 for number 2. Number 3, how do we set that one up as a radical? Fourth root of 81 all raised to the 3rd power. So what is the 4th root of 81? So then it's 3 to the 3rd power. What's 3 to the 3rd power? 27. Raise your hand if you got 27 for number 3. Do y'all understand how this is set up? Denominator, index, numerator is what you do to everything. Okay. So now I'm going to show you how to do it with your calculator. I'm going to get another page of notes. Approximate with a calculator. Get your calculator turned on. Now, when it says approximate, that means round, right? So we're not going to get exact answers. So when we're doing it without a calculator, we're getting exact answers. When we're doing it with a calculator, we're rounding. So those are not technically mathematically correct. So we cannot say it equals. So the way we show that it does not equal, but it's close to it, we do those little squiggle equals. That means approximately. So make sure you do those because it does not equal. We're just approximating, we're rounding. So let's first do one. This is example, what letter are we on? H. Example H, let's do 9 to the 1/5 power. I know this is the same thing as the 5th root of 9, which is not possible to do and get a whole number. So the way we're going to type it in our calculator is this. You're going to hit 9. You're going to hit rooftop. You're going to hit parentheses. 1 divided by 5, parentheses, and then you're going to hit enter. So those are your keystrokes. So, in your calculator, you're going to say 9. I got to turn mine on first. Clear, clear, clear. 9, rooftop, parentheses, which are above the 8. 1 divided by 5. Close parentheses, enter. And let's round to 2 decimal places. 2 decimal places. 2 decimal places would be 1.55. So approximately, make sure you use the squiggles, not the equal sign. 1.55. So you're going to do your base, rooftop, parentheses, put your fraction in. Close parentheses, hit enter. And it might work if you don't close your parentheses. I don't know. I haven't tested it out yet. Let's do another one. 12 to the 3/8 power. So you're going to hit 12, rooftop, parentheses, 3/8. Right? But we're rounding it to 2 places, so what does that 9 do to the 3? Makes it go to a 4. Did y'all get approximately 9.54? So I'm going to say approximately, sorry, 2.54, not 9.54. 2.4. That makes sense? All right. What if they give you the problem in a radical form? What if they want you to approximate this in the calculator? Break it down how? You're close. Yeah, so you make it a fractional exponent. So your base will be the number in the radical. Very good. And then that's your numerator, your index is your denominator. Very good. So then you type it in like that. So you hit 7, rooftop, parentheses, 3 divided by 4. Hit enter. All right, what does that round to 2 decimal places? 4.30. Don't forget to put squiggles, because it does not equal. We're rounding. Questions? Together, or you already do something by your own? We haven't done a negative one. Let's do a negative one. J, this is K. Let's do a negative. 64 to the negative 2/3 power. Now, when you do that, after you do parentheses, use the little negative, and it should work. So you're going to hit 64. We'll see if we get the same thing. So I'm hitting 64 rooftop parentheses. Use the little negative at the bottom. So -2. Stop. Oh, mine went away. 2 divided by 3. Did y'all get that? So 0.06. 2 decimal places just stops after the 6, though, doesn't it? Yeah. So approximately 0.06. We good? You guys try this one and this one. Gave you one with a fraction, one with a radical. You gotta make a fraction. Round your decimals to 2 places, please. All right, I'm going to plug mine in. See if y'all got the same thing as me. For the first one, I'm going to have 4 rooftop parentheses 2 divided by 5. I'm getting approximately 1.74. Did y'all get that for the first one? Now, first thing I need to do on the second one is make it in rational exponents, which means the fraction. 16 to the 4/5 or 16 to the 5 over 4? Yeah. The denominator is the index. Okay? So y'all did that. 16 raised to the 5 over 4. You get a whole number? You should have. 32? Y'all get 32? It's equals. If you're not rounding, it's equals. Y'all understand? Yeah, because you did it the other way. Y'all understand? The denominator will be your index and vice versa. All right, so the last thing we're going to do with this is solve equations. Solve equations with nth roots. Nice. So, example L right here. 4x to the 5th power equals 128. So, my darlings, first I need to get that x by itself. Very good. Divide both sides by 4. So that's 32. So x to the 5th power equals 32. Well, how do you think I get rid of a 5th power to get x by itself?
Put the radical so it cross out the thing.
So to get rid of a 5th power, I take a 5th root, right? Just like square roots take out of x squared, right? So that's what I do. I'm going to take the 5th root of both sides. And the 5 and the 5 cancel and leave you with x. And what is the 5th root of 32? 2. And there's my answer. So that's not so bad, is it? So whatever the exponent is, that's what root you take on both sides. Let's see a more complicated one. Parentheses x minus 3 to the 4th power equals 21. Now that variable is in the parentheses, right? And I can't just get it by itself until I get rid of the exponent. So how do I get rid of that 4th power? How do I get rid of the 4th power? Take a what? Take a 4th root. And what you do to one side of an equation, you got to do to the other side. So those cancel. And that leaves you x minus 3 equals the 4th root of 21. Now I'm leaving it like that because I can't take the 4th root of 21 and get a whole number, can I? Also, something I need to consider is this is an even exponent of an even index of a positive number, so I really need to consider the plus and minus. Right? Because if we take an even nth power or nth root of a positive number, I need 2 real roots. So I need a positive and a negative. Now, how do I get the x by itself? I'm going to add the 3 to both sides. So, what I really have here is 2 solutions. For one solution, I have the positive 4th root of 21 plus 3. And I also have the negative 4th root of 21 plus 3. That's what that plus and minus means. Okay? So what I'm going to do is I'm going to evaluate this in my calculator and round. Okay? So a 4th root is the same thing as what power? A 4th root is the same thing to what power? 1/4, right? A cube root is the same thing as a 1/3 power. A square root, same thing as a 1/2 power, right? So in my calculator won't take fourth roots, but it'll raise it to a 1/4 power, won't it? So that's what I'm going to do. I'm going to say I'm just going to say 21 rooftop, parentheses, 1/4. And you can go ahead and put your +3 in there and get your whole answer. Just type it all straight in there. Does that make sense? Hit enter. Yep. So x is approximately, since I'm rounding, 5.14. And for the other one, I'm going to do the exact same thing, except for at the very beginning, I'm going to put a negative. I'm afraid this ain't going to work, though. What I need to do is say -1 times 21 raised to the 1/4 power. Because if I put the negative on the 21, I typed that in wrong, didn't I? If I put the negative on the 21, it's going to change it to a positive, and I don't want to do that. And I'm going to go ahead and put my +3. Y'all see my keystrokes up there in my calculator?
0.85. Well, 0.86.
Yeah, it should be around 0.86. Did y'all get that? So x is approximately 0.86. So if it doesn't come out evenly, just round it and make sure you do squiggles. If you take an even exponent, remember you got to consider the positive and the negative. Okay? Let's do one more, like that one, because those are really the hardest ones I get to. So, parentheses, x minus 8 to the 5th power equals x minus 8 to the 5th power equals 100. So we want to get x completely by itself. Let me give myself some space, y'all. So what do we do first? Take the 5th root of everything. Cancel, cancel, x minus 8. Now, if I'm taking the odd exponent, do I have to do plus or minus, or just take it as it is? Oh, no. It's odd, so I just do it like it is, right? So I only have one solution. Can we take the 5th root of 100, though? No, I'm just going to leave it alone because it will not simplify without doing a decimal. And then how do I get the x by itself? Add 8 to each side. So you just type that in your calculator. X equals the 5th root of 100 plus 8. And how do we say the 5th root of 100 in our calculator? 100 to the what? 1/5. Very good. So that's what we're going to do. We're going to say 100 raised to the parentheses 1/5. Round to 2 places, approximately 2.51, like KD said. Everybody getting that? You good? Do what? Oh, I didn't do my +8, did I? So if you like me and you forgot to do your +8, typing it straight in, just hit +8 right here, and it'll store your previous answer. And it's 10.51. Does that make sense? Approximately 10.51. Very good. So you can type it straight in, or you can go ahead and enter and then put +8. So that is the end of section 6.1.